Hello, everybody, and welcome to Physics 205 College Physics 1. I just gave this lecture, and then we found that the camera wasn't recording. So we're going to try it again, and this time more better. My name is Greg Francis, and this is not my first rodeo. I've been here at Montana State University for 28 and a half years. And I've been teaching this class for that long. And I'm hoping one day, maybe this semester, hoping one day to get it right. And so we're going to try our very best. Now, the topics that we'll be covering in Physics 205 are the foundational topics: motion, forces, energy, momentum, buoyancy, rotational motion, and torque. Now, if you're watching this video on YouTube, but you're not a student in Physics 205 at Montana State University, I would encourage you to skip ahead to the next lecture, because all we're going to do in this lecture is talk about the course, talk about the housekeeping issues that every course has to deal with, so that we're all on the same page. So if you're not taking the course, just jump ahead and learn some physics, okay? Okay, now, for those of us that are still left behind here, let's start with a commercial.
Have you ever worked with Dr. Francis?
Oh yeah, he's okay.
Just okay?
Guess who just got reinstated? Well, not officially. Nervous?
Yeah.
Yeah, me too. Don't worry about it. We'll figure it out. I'll see you in there.
Just okay is not okay.
Let's talk about the textbooks for the course. Years ago, we were using Cutnell and Johnson, which is the most popular textbook for this type of course, used all across the country. And that textbook cost about $240. Now, in 1998, my friend Jeff Adams and I were team teaching this course, and we found that we really didn't like Chapter 6 in that Cutnell and Johnson text, the chapter on energy. And so we did something that we had never done before. We asked our students to please don't read Chapter 6. We were astonished at their response. They said, sure, fine. We didn't read Chapter 5. We didn't read Chapter 4. We found that they weren't reading the chapters because there was too much in those chapters that wasn't helping them get ready for the midterms. There were sidebars on how their electric toothbrush worked and things that they just didn't feel like they needed. And so Jeff and I sat down and we wrote a chapter on energy to replace the one we told our students not to read. And then we found we didn't like the chapter on forces, so we asked our students not to read that chapter. And we rewrote a chapter on forces. And over time, we ended up rewriting all the chapters and essentially writing a book. Now, when we wrote that book, it had a very different philosophy than the traditional books that it was replacing. Each chapter was very short, and the language was a very relaxed conversational tone. And we also took a different approach to what ideas were presented and how they were presented. What Jeff and I did is we tried to imagine a student in our office 2 days before the midterm. And that often happens. And that student says, Greg, Jeff, I just don't get it. I've been to all the lectures. I did the tutorials. I did the homework. I just don't see it. And then we asked ourselves, what would we do for that student? What would we tell that student that would bring it all together, that would paint the picture, that would help them see just how easy it is if you look at it right? Okay? Now, that textbook was published here at Montana State for years and years and years. And then our good friend Ron Hellings approached us, and he asked us if he could rewrite the book for a national audience. And that's what happened that produced this textbook that you bought at the bookstore. Now, we went with a particular publishing company, University Science Books, to keep the cost low. This publishing company specializes in low-cost textbooks, and they do that by using what they call four-color printing. Now, what four-color means is red, pink, gray, and black. So really, it's just black ink and red ink. If they use a lot of red ink, they call it red. If they use a little bit of red ink, they call it pink. Okay, but really, it's just red ink and black ink. And so we kept the price very, very low for this textbook. Now, there's a second textbook in this class that's used in the lab portion of the class. Now, this is called Tutorials in Introductory Physics, and it was developed by Lillian McDermott and her research group at University of Washington. Now, Lillian McDermott is the very first person in the universe to essentially offer a PhD in the field of physics education research. The first individuals to get their PhD in physics education research were all students of Lillian McDermott. She created the field, which is now a very thriving field, of physics education research. Now, she was working with elementary school teachers and high school teachers and trying to figure out, along with her research group, why physics was so hard. Why physics caused so much trouble when students were trying to learn it. And what she found out is that physics is hard because you come into the class already knowing physics. You can come to college and not know much about chemistry, but you can't come to college without knowing a whole lot about physics. And that's because you live in a physical world. You use tools. You took driver's ed, you drive. And as you live in that physical world, you teach yourself physics. And if you're like me, and you're like most of the people on this planet, you taught yourself a whole lot of physics that's wrong, that's just not consistent, that doesn't fit together. Now, learning something new is hard, but not nearly as hard as trying to unlearn something. That's really hard. Now, the approach that Lillian takes is kind of a drastic one. What she does is she gets you running in a direction where you think you know the answer. You're sure you know the answer. You're thinking this is trivial. And then she rams you up against a brick wall where your predictions don't match with what happens. And suddenly you have to piece together your view of the universe. Now, that particular approach to learning has one flaw or one difficulty to it, and that is you have to be wrong, but not just regular wrong, you have to be wrong in public, and that's the hardest kind of wrong. And the only way we're going to survive that experience is if we agree to be friends. I mean, you've done stupid things in front of your friends before, and laughed about it later and said, oh man, wasn't that so funny? We were down in Mexico and we got put in jail. Anyway, if we all agree that it's okay to be wrong, it's okay to have wrong ideas, as long as we're open-minded enough to examine those ideas and try to fix those ideas. And then it'll be okay. And then we'll survive. Okay? Now, the reading assignments are on that class calendar that I sent out in the email a while ago. And it will tell you which chapters you should be reading at any given time. Now, I would encourage you to read those chapters slowly. Okay, this is not a novel. Okay, the chapters are short, but they're condensed. The most important ideas that you're going to need going into that midterm are in there. And you need to essentially wrestle with them. If you're just skimming, you're not learning. Okay? Now, when I was your age, and that's a million years ago, and I was taking this introductory class, I found that it was best for me to read every chapter 3 times. The first time I would read it would be before the lecture. The second time I would read the chapter was before I did the homework. And the third time I would read the chapter was the night before the exam. But I'm here to tell you, I was a geek, and I had no social life, and you're going to have to decide for yourself what works best for you. Now, let's talk about the lectures in the class. Now, attendance is very strongly encouraged. And we're going to talk about this in a little bit, but associated with every lecture, there's going to be a short, very easy lecture quiz. And the main purpose of this quiz is to make sure that you don't get behind. What I found in earlier semesters is that some people just put off their class until right before the midterm or the final, and then suddenly they were binge watching the lectures like it was some Netflix series. That's not the way to learn physics. Physics needs time to percolate, for the ideas to settle in and for you to wrestle with them for a while. And so we're going to encourage you to stay current with the lecture schedule. And we're going to do that with little lecture quizzes. Now, the lectures are available at YouTube. I've put together a channel. I'm going to show you that in just a minute. On Mondays, I will give you a pretest. Now, in the good old days, that was a paper pretest that I would pass out to the class, and they would take that pretest and turn it in. Of course, given our situation now, I can't do that. And so what I will do is I will email out that pretest, and you can take it at home in your jammies, and you'll never turn it in. Now, this pretest has 3 purposes. The first purpose is to help you see that maybe you don't see. Okay? I've got one pretest that I know that every single class is going to, 95% of the class is going to get it wrong. I've just seen that over and over again. I also see that 100% of the class thinks they got it right, thinks that it was the easiest test they ever took. And so that pretest helps them to see that, oh, maybe I don't see. Maybe I don't have the right idea here. Now, the second reason for that pretest is to train my teaching staff. This type of teaching that I'm using works best when we have one instructor for every 7 students. That means I have to have a huge teaching staff. I've got a bunch of grad students that work for me. I've got a bunch of undergrads from previous years that work with me. If at the end of this semester you find that you did really well in physics and you liked it, you had fun, consider coming back and helping me teach in future semesters, okay? You can be a peer instructor and help me teach this course. Now, because I have so many people helping me teach the course, I have to get them on the same page. If these people aren't teaching the physics in the same way, that's just going to frustrate you all to heck. And so what I do is I bring all of those teachers together on Tuesday, and we go through the material pretending to be students. And the first thing I do with those teachers is hand them that pretest and make them take the pretest like you did. And I look over their shoulder to make sure they don't have the misconception, the wrong idea that we're trying to approach or overcome. Then I hand them a stack, a paper stack, of pretests that were taken by students. Not yours, because you're not turning yours in. But in past years, I've collected them, and I've got stacks of them in my office. And so I hand those to my teachers, and they read through those pretests. And that helps my teachers figure out what it is that you're struggling with. Some of my grad students come into that meeting thinking that you're having trouble with the calculus or the equations. But when they read through your pretests, what they find out is that's not it at all. That's not what you're struggling with. Some of you are struggling with just the idea of velocity and acceleration and how they're different. And so this is a way of training my teaching staff and getting them all on the same page. The third reason for that pretest is that by Friday of each week, you're going to know the answer to that pretest. And you're also going to know that it's not the answer you gave on Monday for most of you. And that means you're going to recognize growth. You're going to see that your view of the universe has changed during the week. And that's going to encourage you to go on. Okay? Now it turns out that in this class, demos are sometimes life-threatening. And here's why. If I were to ask you, if you were actually here, how many of you are taking this class because you have to take the class? It's required for your major. Every hand would go up. I don't believe for a second that there's anyone in here that's just taking the class because they thought that would be fun. Oh yeah, let's just go take a physics class. And I find that a lot of people put it off till their last year of their college education just because they're trying to avoid it. As an instructor, I accept that as a challenge. I feel a responsibility to make this class as interesting and as engaging as possible. And I discovered 28 years ago that the closer the professor comes to death, the more you pay attention. And I try not to take that personally. But that's why I do demos like the bed of death. When we start talking about impulse and momentum on the 17th of March, I'm going to lie on this bed of death. We're going to put the chest plate of death on my chest. The cinder block of death goes on the chest plate of death. And then one of you, the angel of death, will swing this sledgehammer of death, crushing the cinder block of death, death all around. And if I live, then we'll talk about impulse and momentum. If I don't live, semester over. Everyone gets an A. Okay? Now, I came about this principle, this idea, as I said, the first semester I was teaching at Montana State University. I was teaching an electronics class, and during that class, I wanted to do a demo involving a great big transformer. So I went down to what was then Montana Power, and I borrowed a great big transformer for my demo. And as I was trying to connect that to the power in the wall, I accidentally connected myself to the wall. 120 volts. Okay? And I was just, I fried myself. I went home that night to my wife, and I was just discouraged. And I said, oh, honey, that was the worst lecture ever. I fried myself in front of the class. Well, 2 years later, I was in Safeway shopping. Some of my students came up to me and said, oh, Dr. Francis, we just love your demos. You know the one we like the best? You were frying yourself. So that became part of the lecture. That worked. Let's talk about that YouTube channel. It's at this address. And this address is on that course information sheet that I emailed out to you. This channel looks like this when you go there. Actually, that's just the top part of it. There's also, it continues down below, and there's the 207 course lectures are there as well. Where you would go is right there. These are all the lectures for Physics 205. In order, okay? Now, these will be the lectures that you'll watch before the first midterm on linear kinematics. These will be the lectures that you watch before the second midterm on linear dynamics, Newton's laws of motion. These will be the lectures you will watch before the third midterm on energy and momentum. And then before the fourth midterm, it will be fluids and rotational mechanics. Okay? Now, I know that for some of us, for many of us, watching a 50-minute lecture, no matter how many times the professor comes close to death, is just not something you want to do, okay? It's just not the same as watching an episode of Friends. And so what I've done is I've broken up each of the lectures, I've broken them up into a bunch of quick concepts and demos, okay? So what I have here are 32 short little videos, about 5 minutes each, that each cover just one particular idea. And so if you just want to take it in bite-sized chunks, you would do this. And if you wanted to just go back and review some of the demos, you'll find those here. Now, if any of you are planning to be high school or middle school science teachers, sometimes at your school you don't have the equipment that you need to do the demos that we can do here at the university. For example, in 207, I'm going to be doing a demo with a levitating track, where I've got a puck that just floats above a magnetic track. Okay? Let me just pause right there. Those of you that go on to Physics 207, that's the good stuff. We're going to talk about waves, music, electric fields and forces and voltage, electric circuits. You'll come away understanding electric circuits, magnetism, induction, all the really fun, sexy parts of physics. But from day one in that Physics 207 class, we're going to be using the ideas of 205. We're going to be using Newton's second law here. We're going to be using the ideas of energy and momentum here. We're going to be using the idea of torque here. Okay? So we have to handle these fundamental principles in 205 so that we can enjoy the good stuff in 207. What I'm doing right now is trying to encourage you to hang on, to keep coming back long enough to get to the stuff that's really, really good. Okay? Now, I would encourage you, I would ask you that since it doesn't cost you anything and it doesn't hurt anything for you, if you just push that button, subscribe. I think if I have more subscribers, I get more privileges as far as posting all these videos. I've got over 400, close to 500 videos up there, and I'm worried that at some point they're going to start restricting me. Okay. I mentioned briefly this idea of the lecture quizzes. Now, those lecture quizzes are going to become available at noon on the day of the lecture. And that quiz is going to close 48 hours later at noon on the day of the next lecture. Now, don't ask me to extend that deadline. Don't send me an email saying, oh, you know, I didn't get around to watching lecture 5. Could you just give me another day? The answer will always be no, because the purpose of that deadline is to keep you up to date, to keep you from putting off those lectures. Now, each of those quizzes is going to be very, very simple. It will have 4 questions. And the first question is always the same. The first question is true or false. I attended or watched online the lecture on blank. And if you hit true, you get 2 points. The other 3 questions are each worth 1 point, and they're just very, very simple questions from the lecture to make sure that you fully inhaled, that you went, you watched it, whether it was in the 50-minute chunk or in the little chunks, that you were there. Okay? Now, it's worth 10% of your course grade. And I'm going to drop the 4 lowest grades. There's 34 of those quizzes, but you're only going to be graded on the top 30 scores. That means you can miss the deadline 4 times and not be penalized. Okay? I think that's fair. Now, let's talk about the tutorial. The tutorial is in this textbook here that was developed by Lillian McDermott and her research group. And again, she had been working with elementary school teachers and high school teachers, trying to help them overcome misconceptions, the stumbling blocks that make physics so hard to learn or unlearn. And then the physics department approached her and said, "You're doing all this great stuff for the teachers. Could you fix our engineers?" And so then she took that 25 years of experience working with the teachers and boiled it down into these tutorials for the engineers to essentially help them overcome the same misconceptions, the same difficulties. Now, I was with her research group at the time when we were putting these together. Indeed, Mark Summers and I were the first teachers to ever take these tutorials into the classroom. And it was a wild experience. We would take these things fresh off the printer into the Monday morning class, and then would come right back to Lillian and Peter Schaefer and say, "Oh, you know what? Page 3 of that tutorial just didn't work at all." And then during lunch would scramble to rewrite page 3, and then would go back in. And by Friday, the tutorials looked very, very different than they did on Monday. But now this publish form has settled down after years of doing that evolution of refining those tutorials. This is what they look like now. And there's 2 volumes. The first volume is the activity that you actually do in the tutorial, okay? And the second volume has a homework assignment that's associated with each tutorial. Now, when we started out, again, years and years ago, we actually had the students turn in the tutorial. And that was a mistake. That was a huge mistake. Because the engineers at University of Washington were so worried about whether they were going to get the right answers written down on their tutorial handout that they didn't talk to each other. They didn't have any kind of engagement where they wrestled with the ideas. And that ruined the whole dynamic. And so what we quickly decided was we changed our policy so that this never gets turned in. The tutorial itself is your property. You can write lots on it or nothing at all, okay? We'll never collect it. The tutorial homework is written in such a way that if you went to tutorial and you participated in tutorial, it's pretty straightforward, the homework. But if you didn't go to tutorial, or if you went and you let the other people do all the thinking and all the wrestling, then you really don't have much chance of getting this right. And that's the way we graded the experience. Now, if your instructor lectures you, they're doing it wrong. If your instructor gives you answers, they're doing it wrong. And I want to hear about it, okay? What they should be doing is asking you questions, engaging you in what's called a Socratic dialogue, asking you questions that will help you build the physics for yourself. Build it from the ground up so that you own it, so that it's part of you, so that you'll never forget it. Okay? That's the way it's supposed to happen. Now, this picture was taken a long time ago. These are instructors pretending to be students, and Michelle here is pretending to be the instructor. Now, let me just tell you about some of these people. This is Kevin Wolverton. He's now a very prestigious doctor at the Mayo Clinic. And he was just teaching lots of tutorial classes for me and did an outstanding job. I imagine he's a good doctor, but he was really a very, very good teacher. But this is the person I want to tell you about above all others. That's Michelle Larson. She was an undergraduate here at Montana State University, and she was my first graduate student here at Montana State University. In 2013, she was hired as the president and CEO of the Adler Planetarium in Chicago. Now, that makes her the very first female CEO of a major planetarium in the history of the United States. And we are very, very proud of her and what she's done. Now, this is her husband, Shane Larson. He's an astrophysicist. He's okay, but we don't brag about him. Okay. Now, as I said, these tutorial activities are what we call guided inquiry. Now, there's all sorts of teaching styles that go under the name of inquiry. You'll hear that a lot. And in some of those cases, they just throw a whole bunch of equipment in the middle of the room, and the students just play with it. And it looks all the world like that old Samsonite luggage commercial where a bunch of monkeys are throwing luggage around. Not effective, not effective. Lillian's approach, as I told you, is to get you going in a direction where you think you know the right answer and then pushing you up against your misconception. It's painful, okay? Sometimes it feels like she's reaching up into your nose and dragging you by your nose hairs to the right answer, okay? And it's built, as I said, on 25 years of careful research as to what works and what doesn't work in helping students overcome these stumbling blocks. Okay? Now, homework, the tutorial homework, is not plug and chug. It's not something that you're plugging into equations and getting a number. They tend to be conceptual questions where you have to explain your reasoning. And these are key to your doing well on the exams, because the questions on the exams are going to be very, very similar to the questions in the tutorial homework. Now, this homework is due the Tuesday after you take the tutorial. Now, you're going to be taking tutorial at different times during the week. We have tutorials that start at noon on Wednesday, and they go every 2 hours until Friday at noon. And so some of us are taking it on Wednesday, some on Thursday, some on Friday morning. But we'll all be turning in our homework before 5 o'clock on Tuesday evening, okay? And we'll turn that homework in at D2L. We don't want to deal with paper. We don't want to handle paper. We don't want to have to find you to give your homework back after it's been graded. So you will turn that homework in at D2L. And you're going to need to turn it in as either a JPEG or a PDF. What works best is if you use some scanning program like Adobe Scanner. And it's a free program you can put on your phone. And essentially you just take a picture of your homework and it turns it into a PDF or a JPEG. Now, what you can't do is just take a picture of your homework with your iPhone and send that picture to D2L. That's a very special proprietary format that Apple uses, and D2L can't read it. And so the grader can't see anything. They can't grade your homework. So if you do that, you're going to get a 0. You should make sure that you're turning in either a JPEG or a PDF. Now, I like Calvin and Hobbes. I don't think the schools assign enough homework. So there's a second kind of homework. In addition to the tutorial homework, I will assign a lecture homework from this textbook every single lecture, except one. There's one lecture that I don't give any homework. Now, at the end of each chapter, we have problems many of those problems are old exam problems. And I know which ones those are. And so I'm going to pick those problems as your homework assignment. And I'm going to give you 3 problems every lecture, except that one. Okay? Now, that homework is due at 5 o'clock the day of the following lecture. So if it's a Monday and I give you an assignment, that's going to be due Wednesday at 5 o'clock. Okay? Wednesday at 5 o'clock. Now, I don't have enough staff to grade all of your homework, so even though you'll be turning in 3 problems, I'm going to randomly choose one of those 3 problems for them to grade, and they'll just grade that one problem. Now, because we all have busy lives and we sometimes have things come up, I'm going to drop your lowest 4 scores. No questions asked, okay? I'm not going to be able to deal with excuses. With 350 students in the class, I can't have, well, would you open up this homework assignment for another 24 hours so I can get caught up? No, what I'll do is I will drop the lowest 4 grades. So you can just not do 4 of the homework assignments out of the 33 and still get a perfect score. Now, there's your first homework assignment. In chapter 3, do problems 7, 8, and 9. Now, chapter 3 doesn't seem like the normal place to start a course. Well, it turns out that chapter 3 used to be chapter 1 when Jeff and I wrote the book. That's where I think we should start, with a review of trigonometry, because we got to get that out of the way. We're going to be needing that. Well, Ron didn't think we needed it until chapter 3. He thought, let's go as far as we can get before we need the trigonometry, and then we'll bring it in. Well, I'm going to do it my way. So we're going to start in chapter 3, and these are just 3 very easy trig problems. Okay? Now, the D2L site is critical for this class in these COVID days with this blended approach to teaching. Okay? So much is done at the D2L site. You can go to the D2L site and find this lecture. All of the lecture notes, the PowerPoint will be posted at D2L. All the lectures will. When you go to take a lecture quiz, you'll go to D2L, and you'll find the lecture quiz waiting for you. You'll turn in your homework, both the tutorial and the lecture homework, as PDFs or JPEGs at the D2L site. And you'll be able to see your grades at the D2L site. Let me show you that D2L site. That's what it looks like. It's pretty basic. Looks like any other class here at Montana State University. There's my email address. This is the address of the YouTube channel here. Now, if you go to this section right here called Content, that's where you would find all the lecture notes, okay? If you were to click on Kinematics, you would see all the lectures. If you click on Course Materials, there's the class information sheet that I emailed you. There's the class calendar that I emailed you. Here's the homework schedule that I emailed you. This absence form is in case you have to be gone, okay? In case you are missing tutorial, you're going to be busy the whole week. You've got a family emergency or something that keeps you away from tutorial. You fill out that form and you'll get your attendance points, but you will still have to turn in your homework, okay? Now, if I go, say, to that homework schedule, this is what you find, okay? And this tells you that on Wednesday, you will need to turn in by 5 o'clock, Chapter 3, Problems 7, 8, and 9, okay? And each of these days indicate what you will have to turn in. Now, that's just one way you can figure out your assignment. There's actually three other ways that I'll tell you about as we go along. Okay? If I go to kinematics, in this, if we go back to the content section and I go to kinematics, you're going to see all the lectures in the topic of kinematics, which means motion in regular talk. Okay? And so these would be the lecture notes. The lectures themselves would be at YouTube. Now, if I go to the main page and go to quizzes, that's where I find the 34 lecture quizzes. And if I click right here, it'll open up the quiz. Okay, that'll open up the first quiz. But you'll notice that's only available for 48 hours, from noon on the first day of class to noon on that Wednesday, the day of the second lecture. 48 hours. Okay. Now, if I go to this part of the web page titled Assignments, that's going to give me all of the homework assignments. And that's the second way you can figure out what's due. First of all, this first homework is due on January 13th at 5 p.m. And if I click that, it'll have the assignment. It'll have which problems are due. And it'll have a place where you can upload your PDF or your JPEG file. Okay? Now, the third way that you can find your homework assignment is by going to those PowerPoint slides. The first slide in every lecture is going to be the homework assignment, and you can always find it there. And it'll be exactly the same as what you see in these other places. Now, the last place, the fourth place that you can find the homework assignment is at YouTube, but not in the video. As I said before, that video was filmed in 2015, and many of the problems that I talk about in the videos have changed their numbering. They're actually sometimes different problems, okay, or different numbers. So don't trust what I say in the lecture video. But underneath the video, there's a description of the video. And in every single case, I've included in that description the homework assignment associated with that lecture. So that's the fourth way you can find your lecture homework assignment. Now, there's going to be 33 of these homework assignments, and at the bottom of that list, there's homework 33. At the bottom of that list, we'll start a new list for tutorial homework. Now, it may be, if you're set up so that you're only showing 20 items on a page, you may need to scroll to the next page. But underneath all of the lecture homework are the tutorial homeworks, where you turn in your tutorial homework. Okay. Let's talk about the midterms. There will be 4 one-hour midterms. 1 hour, I mean, I will write them such that most of you will be able to get them done in 1 hour. But I'm going to give you 2 hours because I don't want time to be a factor. I don't want anyone to feel rushed, okay? Now, what I don't know yet is how those exams are going to be administered. Last semester, I got special dispensation from the university to offer exams on campus. I reserved lots of huge rooms so that we could spread people out and social distance and still take paper exams on campus. And I did that because I wanted to read about your reasoning. I didn't want to just see your answer. I wanted to see how you got your answer. And I think that's the best way to have an examination. Now, I've asked the registrar's office for that same kind of dispensation, the special permission they gave me last semester. They have not yet responded. Actually, they've responded and said, we're not ready to make a decision. So it probably, I probably won't know until the semester starts whether we are going to take our exams on campus in lots of rooms around campus, or whether we're going to take multiple choice exams on D2L. But I will let you know as soon as I know. Now, I like Calvin and Hobbes. Explain Newton's first law of motion in your own words. Jakob Mug, I love loopholes. Again, we're going to do better at explaining our reason if they let us. Now, your grade in the class, each of the midterms is worth 15% of your total grade in the class, for a total of 60%. Now, each of those midterms will cover primarily the material that we've covered since the last midterm, meaning the last midterm, which is during finals week, will really just be covering that material since the third midterm. Now, we're going to be responsible for using the ideas that were covered earlier in the semester. Once you learn how to deal with forces, you have to keep using those ideas, but I won't specifically target those ideas as the main part of the problem. Now, the tutorial homework is worth one midterm, 15%. But 10% of that is the actual homework itself that you turn in at D2L. The other 5% is attendance. You need to show up at that team meeting. You need to be recognized by your instructor as being there so that you get those 5 attendance points. And if for some reason you can't be at your tutorial, if you go to another tutorial, as I said, we've got them all week long, you need to have that instructor contact your instructor to give you those attendance points. The lecture quizzes, as I said, are worth 10% of your grade. All of the lecture homework, all 33 combined, add up to be one midterm, or 15%. And that gives you 100% of your score. Now, as far as the grades in the class, because we have so many pre-med students in this class, I feel like I really want to give about a third of the class an A. And over the many years, what I found is that if I have a strict cutoff of 90 and above as an A, I'm not going to have enough A's. And so what I've adopted over the years is a more lenient, a more generous breakdown where the cutoff for an A minus is 85%. Now, I bring that up because D2L is not so lenient. And D2L has a color scheme where they're constantly telling you whether you got an A, B, C, or D on an assignment. But their color scheme is very, very strictly based on the 90 and above as an A. And so if you buy into that color scheme, you're just going to be depressed, okay? So what I want you to do is pretend you are colorblind when you go to your grades at D2L. Don't let them tell you what you're getting, okay? Use that information sheet that I sent you in the email. That's what we're going to use to assign your grade in the course, okay? Now, my office hours, Monday, Wednesday, and Friday from 10 to 11 before my first lecture, I will always be in my office. And if you want to come into that office with a mask, social distancing, you are welcome. I will also have my laptop open to that Microsoft Teams channel that's titled Greg Francis Office Hours. And I've sent you the link to that channel. Now, whether you want to come in person or whether you want to come in virtually through that channel, either way, I'm happy to help you with the physics. But more importantly, those are not the only hours. Anytime I'm in my office, and I have lots of time on Tuesday and Thursday when I'm not lecturing, that you're just welcome to walk on in, okay? I teach large lecture classes because I love to teach. We have people in this department who teach one class with 8 students and do a whole bunch of research, Okay? I teach a lot of the large classes so that they can do that. And it works out for everyone. Because what I love to do is teach you. When I come down to this lecture hall, I'm grinning ear to ear. I'm looking forward to it. So if you see me in my office and you've got a question, come on in. Or if you don't want to come to campus, send me an email and say, can you meet me in your office hour team channel? Okay? And I'd be happy to meet you there. Now, remaining issues, academic honesty, cheating. I've been here 28 years and I've had almost no problem with cheating. And that's because you're good people. You're honest. And I don't blame you. It's not your fault. Your parents raised you right. Your parents raised you right. Now, I discovered this on my first semester through an experience that I'll never forget. Back then, we were giving the exam late at night, and we were staying up and grading until the middle of the night. And at the end, at 3 in the morning, we were adding up the scores. Well, as you can imagine, mistakes often get made at 3 in the morning. And so the next day, I was handing back the exams, and some students came up and said, oh, you didn't add up my score right. I should have got more points. And I'd fix it. And then a student came up, her name was Elizabeth Lyons, and she said, you gave me 10 points too many. Now, I'd never experienced that before. I'd taught at MIT, I'd taught at Brigham Young University, I'd taught at University of Seattle, University of Washington in Seattle. Never happened. So I said, look, we made the mistake, you keep the points, go sit down. So for 50 minutes, I went over a review of that exam. At the end of the 50 minutes, she came up with tears streaming down her face and said, I didn't earn those points. I can't keep them. And that's when I fell in love with Montana. That's when I fell in love with Montana State University. That's when I decided that I was going to be buried here in Bozeman. Okay? You are wonderful people. Now, tutorial absences, I think we've already talked about that. Fill out that absence form. Getting help. Physics builds on itself like a house of cards. If you don't understand kinematics, you have no chance whatsoever of understanding dynamics. If you don't understand dynamics, you're really going to have a hard time with energy and momentum. It all builds. What that means is if you miss a lecture or if you don't understand an idea and you fall off that bus leaves you, okay? And what you need to do is you need to get back on that bus as soon as possible by getting help. You need to come to me, you need to come to your lab TA, you need to somehow get back on that bus, because if not, you're going to get dragged all the way up to that next midterm and you're going to fail, okay? And the sooner you get back on that bus, the easier it's going to be, because every lecture that you go to after you've misunderstood something is going to be a mystery. It's just going to get more and more confusing. Got to get help. Get help, people. Okay. Quick questions. Okay. These are just some fun questions. A large truck collides head-on with a small compact car. During the collision, A, the truck exerts a greater amount of force on the car than the car exerts on the truck. B, the car exerts a greater amount of force on the truck than the truck exerts on the car. Or C, the truck exerts the same amount of force on the car as the car exerts on the truck. Think about how you would answer that question. Now, in a regular semester, when people were filling this room, I would have them use their clickers to actually vote. And what I would find is that we've got about a third of the class voting for each of those options. We don't know, okay? Let's try this one here. An elevator is being lifted up an elevator shaft by a steel cable. When the elevator is moving up the shaft at constant velocity, is the upward force on the elevator by the cable greater than, equal to, or less than the downward force by gravity, the weight of the elevator. Think about that one. Again, if this were a regular semester and we were using clickers, we'd find that about a third of the class would vote for each of those options. Now, these two questions are part of an exam called the Force Concept Inventory, the nastiest multiple choice test that was ever written. It was put together by a research group in Arizona headed by David Hellings. And what they did is they did interviews with hundreds of students, and they found the most common wrong answers to these questions that they were asking. And they used those most common wrong answers, these most common misconceptions, as the distractors in the test. Now, there's 30 questions on this multiple choice test, and each question has 5 possible answers, A, B, C, D, or E. That means if you put a blindfold on and you just randomly choose your answers, the law of averages says you're going to get 20% on that exam. If you take off the blindfold, your score typically goes down. And that's because the wrong answers are so tempting. Pick me, pick me. This is what you've believed your whole life anyway. Now, what we find is that when we give this exam in a physics class, on the first day of class and on the last day of class, for most classes that are lecture-based, where most of the learning happens in a lecture like this, almost no improvement happens during the semester. Almost none. Okay? Now, I've given this test on the first day and last day of class for years. And what I found over and over again is that we had some of the highest gains in the nation. We reported some of the highest gains on this exam from the beginning of the class to the end of the class. Now, I explained that by saying the tutorials must be where the students are learning. Because I'm just doing a regular lecture like every other instructor on every other campus. The only thing different about this class is that tutorial where we have the inquiry approach to learning that was developed by Lillian McDermott. So that's how I explained these gains. Well, years after I started teaching here, we hired my friend Jeff Adams. And when he arrived, he looked at these gains and he said, "You know, Greg, I don't think that's it. I think you teach your students what the misconceptions are, and so they know how to miss them. And that's why they get the gains." But he said, "You know, that's not going to last. You know, if you were to bring those students back after years and give them that same exam, they'd be back where they started. They'd have the bad exam scores again." Well, that gave us an idea. What we decided to do was call all of our previous students and see who's still living in the valley. And if they're still living in the valley, we offered them $10 to come down on a Thursday evening and take what we told them was a survey. We didn't tell them it was going to be that test again. We never gave them a copy of the test. We never told them what the right answers were. But they came back 3.5 years later, and this is what happened. Okay? This is the first day of class. This is the last day of class. And this is 3.5 years later. Once you build these ideas of physics from the ground up in such a way that you own the ideas, they never leave you. It's like riding a bike. Okay? That's my message to you. Now, I sent you in that email a math test. That math test you will never turn in. We're going to talk about the answers to that test in our next lecture. That test is for your benefit. What I find over and over again is that the students that fail Physics 205 don't fail because they don't understand the physics. They fail because they can't do the math. Their algebra skills are not what they need to be. Now, here's how you're going to use that test to figure out whether you should stay in this class. If you work those problems and find them easy, and you find next day that you got the right answers, you're fine. You're going to be just great. Take the class. You'll love it. If you take that test and find that it's hard, and when we come back on the next day, at the next lecture, you find that you miss some of the problems. But as I go over the problems at the board, you say, oh yeah, I knew that. Oh yeah, I see what I did wrong. You'll be fine. You'll be fine. Take the class. But if, while I'm going over the answers to that test, you're still lost, you still don't see what I'm doing, you need to drop this class. You need to take an algebra class and then come back. Otherwise, it's just going to be a miserable experience. Folks, we have run out of time. I am looking so forward to this opportunity to work with you this semester. We are going to have fun. It's going to be hard. It's going to be challenging because of our special situation with social distancing. But we can do it. We can get through this. Thank you.